Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Advanced Threat Tactics Part 9, Evasion. I'd like to start out this final lecture with a little bit of evasion philosophy. I get a lot of questions about evasion, and so let me just put it right out there. Cobalt Strike is not a magic wand to defeat each defense and scenario you will encounter, okay? As a vendor, as a developer who's working with your team, I simply cannot guarantee that. Nobody can. What Cobalt Strike does provide is options and flexibility. And we'll go through those in this particular lecture. I really believe that evasion is the operator's responsibility. When you're working on a target, you are in the best position to assess what's going on, understand the defenses that are in play, and make the best decision about what to do. No one thing in this tool set, or any tool set, can deal with every possible situation you're going to encounter. So with that, let's jump into this lecture on evasion. We're going to start out by talking about email defenses, and we're going to talk about DKIM, SPF, and DMARC. We'll spend some time on antivirus. We'll talk about application whitelisting. We'll talk about getting past restricted firewalls and a little bit about tradecraft for dealing with active defenders. So let's jump right into it. What are DKIM, SPF, and DMARC? DKIM, SPF, and DMARC are add-ons to email to help identify spoofed messages. As the attacker, your counter to these standards is going to be to send an email from a domain that you control that opts into these standards, or to be very careful to only spoof a domain that does not opt into these standards. To understand these defenses, we have to talk a little bit about SMTP and how email is sent around the internet. When I opt to send a message to Rafi@strategiccyber.com, my mail server is going to do a DNS lookup for the MX record for strategiccyber.com. The MX record is the mail exchanger record for domain. It states which servers are willing and able to accept email from outside parties like myself. I, the relaying mail server, am going to connect to one of those mail servers on port 25. And then I'm going to have a little conversation that goes something like this. First, I'm going to introduce myself. Let's pretend my relaying mail server is whatever.com. So I'm going to say, hello, I'm whatever.com. The next part of the transaction is what is called the envelope, okay? That's the mail from and recipient to part of the transaction. Much like an envelope in a real physical mail transaction, the envelope does not necessarily have to correlate with the content of the letter, okay? The envelope just indicates who the message is from, who it's going to, and it serves a very important purpose. And that is, if something goes wrong sending the message to the recipient, the envelope tells the mail server where to send the message back. And that's called a non-delivery notice when a mail server opts to bounce a message. And so the mail from piece indicates where the message gets bounced to. So my mail server introduced itself with hello, whatever.com. It says, I've got mail from some bounce address at whatever.com. If something goes wrong, send it here. And I've got a message for this person, this recipient, okay? And here's the message content, and that goes after the data line. So I said, got some information for you. Here's the data line. I send the actual message with all of its headers and everything else. And then I end the message with a period on a line by itself and quit. And that's the whole transaction to send an email. Okay, earlier we conducted a phishing attack and the result looked something like this, right? Well, let's take a look at what that looks like by hand. First, we're going to modify our template real quick. And we're going to do the same thing Cobalt Strike would do. Let's basically strip out all these unneeded headers. Okay. And I think the rest of this is okay, so we'll leave it like it is. Next, we're just going to go ahead and copy this to our clipboard. Now, let's go ahead and connect to our test network's mail server. And we'll do hello, attacker.com, mail from test@attacker.com. This is the envelope. Recipient 2, Jim Stevens at acme.com. Data, paste in the actual message content, a period, and that's it. That's the process to send email. Oops. Let's come back here, hit refresh, and display the images, and there you go. Same fish. Okay? So, what are these different defenses we have to deal with? Well, one of the defenses is something called Sender Policy Framework. Sender Policy Framework is a defense that a domain owner may opt into. All they have to do is publish a TXT record in the SPF format. And this SPF formatted TXT record states which domains or networks are allowed to relay email on behalf of a particular domain. So let's say I don't actually have anything to do with whatever.com, but I opt to connect to a mail server, say, hello, I'm whatever.com, and I've got mail from bounce address at whatever.com, and here's who it's for. Well, if the owner of whatever.com publishes an SPF record, that mail server can look at that SPF record, it's just a text record lookup anyways, and check if the address I'm coming from to relay email is really in that record or not. And if it's not, the mail server can immediately know something's going on. And that's Sender Policy Framework. Sender Policy Framework is a way to prevent spoofing of the envelope. The next one is Domain Keys Identified Mail, DKIM. The purpose of DKIM is for a mail server to actually sign a message in the headers in such a way that another mail server can look at that message when it comes through, pull the signature out of the headers, and validate whether or not the message really came from that mail server by using information published in TXT records for that particular domain. So that's Domain Keys Identified Mail. It's a way for a mail server to actually say, hey, I handled all of this content. Here's my mark on it. That really did come from me. Now, where DKIM is interesting, or where it really came from, was a long time ago, Yahoo, Microsoft, Google, and others got together and said, we've got a real problem. Several domains, several key domains, like the IRS, PayPal, and others, are constantly being spoofed in different phishing attacks meant to defraud these webmail users. So these organizations said, what if there was a way we could convince PayPal, the IRS, or other members of these heavily phished domains to certify that a message came from their mail server? And this lack of certification by itself doesn't mean anything, but if it's there, we know the message is indeed likely to be valid. So the standard they came up with was Domain Keys Identified Mail, which was a way for them to do a handshake agreement with PayPal, the IRS, and owners of these other heavily phished domains and say, hey, if we see a message come from your domain, we're going to look for that header. And if it's not there, we're going to assume it's spam. And those domain owners said, that's cool. We'll sign our messages at our mail server with this particular standard. Now, this mechanism really depended on the two parties agreeing to work with each other. the webmail providers agreeing to validate that information, and the owners of these heavily phished domains or heavily spoofed domains agreeing to actually sign their messages in this way. On the internet, though, it's not really tractable for every party to make an agreement with every other party to say we're going to do things this way, or at least not to do that one-on-one. There needed to be a way for domain owners to tell mail servers that know about these protections that, hey, I'm a domain owner. If I opt in these protections, you should look for them and you should verify that messages coming from my domain pass these protections, and if they don't, take some action. And that action might be warn the domain owner that messages are failing because maybe they have something misconfigured, or it might be, hey, I, the domain owner, trust my setup. I'm now going to tell other mail servers to automatically block or swallow any messages that don't pass these standards. So that standard did come about, and that standard is DMARC, the Domain-Based Message Authentication Reporting and Conformance Standard. The whole purpose of DMARC is for domain owners to say, hey, I use SPF, I use DKIM, you should check for these things, and if either of these checks fail, here's what I, the domain owner, want you to do. You can check if a domain owner opts into DMARC by doing a dig plus short, pull a TXT record off _dmarc.whateverdomain.com. Okay? Finally, the last anti-spoofing technique I want to touch on is accepted domains. This is a Microsoft Exchange feature, and all it does is let the owner of the mail server say, hey, these are my domains. They should only come from an internal address of some sort. Do not ever accept email from an external server claiming to have email from one of these domains. It's not. And that's the accepted domains feature. Okay, let's take a look at the, let's just do a dig txt on paypal.com. And here you can see paypal.com has an SPF record that says include these different hosts, okay, and deny everybody else. So that's an example of an SPF record, if you're curious about that. Let's do dig text _dmarc.paypal.com. Okay. And here we can see they're opting into DMARC version 1. And if something fails the different checks, they should be rejected. So that's an example of DMARC and what it looks like when a domain opts into the DMARC protections. So when you use Cobalt Strike to send phishing emails, here's my advice to you. First, the bounce address. Let's talk about that. The bounce address in Cobalt Strike's phishing dialog maps directly to the mail from portion of the envelope. You should check that that domain does not have an SPF record. You should also make sure not to use your target's domain in the bounce address, because what's going to happen is when you connect to your mail server and say, hey, acme.com, I'm acme.com as well, here's a message from whoever at acme.com, that mail server is going to immediately say, I don't know who you are, you need to authenticate. And so that's not going to work out for you. In some cases, many spam filters will look at the data portion, the actual email message, look at the from header, and compare it to the bounce to address. And if the bounce to address and the from header in your email do not match, that is an immediate spam indicator. So be aware of that. Okay, let's talk about the SMTP server. You can use the mail exchanger record of the target's domain. That's totally cool. Just make sure you take into account DMARC and SPF and these other indicators I'm talking about. So keep that in mind as well. When you do an embedded URL, don't do an IP address. Make sure you use a fully qualified domain name. That URL does get replaced in the template. One thing to say is with a fully qualified domain name. Another spam indicator is if you have a link in the HTML portion of the message and it links to yahoo.com, but you happen to have in the href portion of the link, you happen to reference like badstuff.com. That too is an indicator, is that mismatching. For the file attachment, don't attach something that's obviously an executable. So don't attach an exe, don't attach an SCR file. Many mail filters by default will automatically drop messages with executables attached. The template corresponds to the data portion of the email transaction. There are different tokens you can use to personalize the message, and you can update URL references that are not enclosed within a link with the %URL% macro. Finally, the recipient to portion is directly driven off the targets file. You want to make sure that target email addresses are in a domain that the SMTP server you're connecting to will deliver to. So if you connect directly to your target's SMTP server to accept messages, you need to make sure you're only relaying messages to acme.com. If you try to relay a message to another domain, the mail server is going to come back and say, hey, I'm not an open relay. I'm not going to allow that.